Hi guys, this is just another video in the series. This one's on adjacency matrices, or as we've called them before, just matrices. The key knowledge in this video is how to turn a graph into a matrix, and then vice versa, how to turn a matrix into a graph. So basically the only new word is adjacency matrix, which is just matrix. A matrix that represents a graph, and then you've got to do questions 1 and 2 in your textbook. So if we have this graph here, we can see that there's 3 vertices, A, B and C, and when you see that, that's going to give you the dimension of your graph. Of your matrix, So I'm going to draw a matrix, and it's going to be a 3 by 3. And how I know that is because there's 3 vertices, I'm going to have 3 columns and 3 rows. So all you do is you just write ABC, or ABCD, or ABCDE, and that would be the dimension of your graph. So because there's 3 vertices, it's going to be a 3 by 3 matrix. Okay? And then all we have to do is look at the connections in the graph by looking at the matrix. So this space here is A to A. So I ask myself the question, are there any connections from A to A? And the answer is 0, because there's not any connections from A to A. Are there any connections from A to B? So this space here is, B to A in this context, B to A, and it's not. I can't see a connection from B to A. Are there any connections from C to A? And there's 2, because I can see there are 2 edges connecting C to A. Okay, and you just go through in sequential fashion like that and fill out the matrix. So it's a pretty step-by-step process. So A to B, again, there's no connections. B to B, there's 1. Okay, so this is the only time you'll ever get a B to B connection is if there's a loop connecting to itself. So in this case, there's a loop on B, so there's a 1 connection from B to B. And C to B, there's 1. Okay, A to C, 2. B to C, 1. C to C, 0. Okay. And you should see there's symmetry in this matrix going down the diagonal, and that represents the fact that the connection of B to A is the same thing as A to B. Okay, that's why there's symmetry there. If I want to know the degree of C, okay, I can do that by looking at my graph. I can say C has a degree of 3. I could also, another way of doing it is by counting, by finding the sum of a column, okay, or the sum of a row. And you can see by adding that up, it has a degree of 3. So that's another way, if you're ever given a matrix, how to find the degree of a matrix. Okay, so now going the other way, turning a matrix into a graph, what I do is I can see here there are 3 columns, so that means there's going to be 3 vertices, and I just put them arbitrarily anywhere I want, so randomly anywhere I want, like that, 1, 2, 3, and then I just follow the graph. So there's no connections x to x, there's 1 connection x to y, like that, there's 1 connection x to z, that. There's 1 connection y to z, so I've already got that. 1 connection y to y, so there's a loop going from y to y. 1 connection y to z, so like that. 1 connection z to, so this bit here, z to x, which I've already got. 1 connection z to y, which I've already got, and no connections z to z. And it wouldn't matter if you drew it like this. This is just a little bit different to the other graph. Oh, if I can connect on my line. that's still the same graph. It's still correct. There's almost infinitely many ways you can do graphs like this. There's probably even a maths behind the way, infinitely many ways you can do it. But as long as you've got the connections right and the degree right, then there's no right or wrong way of presenting it. Okay. So good luck. Any questions, email me and I'll get back to you soon.